Hi, my name's Marvin Goodman. I'm a product manager at IBM. I'm going to take a few moments to tell you about a new offering in the cloud management space called Smart Cloud Monitoring. Now, Smart Cloud Monitoring is a new name, but it's not entirely new technology. It's based on the enterprise monitoring technology that's running in some of the world's largest data centers. What we've done is taken some of that technology and built new visualizations and new deployment mechanisms and wrapped it in a new bundle with a convenient pricing metric to make it really handy for folks that are taking a virtual environment that may be running in their data center and trying to position that as a full-fledged private cloud offering. Focus is going to be on management and administration of that environment and maintaining the availability and performance. The product has been out since December of 2011, but like I said, the technology is not brand new, or not all of it anyway. You'll see some new features that we've built in if you're familiar with IBM's infrastructure management offerings. One major cloud service provider that was part of our early adopter program, they consolidated 59 development and test labs down to 6 centralized labs, and in the process they calculated a 14.2% return on investment for their investment in Smart Cloud Monitoring. We've seen other customers that have moved into production this year after being part of our beta during the development phase increase VM density by 58%. What the tool offers is simply cloud health visibility and optimization. We're going to see how some new visualizations have been wrapped around our traditional way of looking at infrastructure data. It's really a foundation for an extensible cloud environment because what cloud doesn't grow? And we've added new capacity planning and analytics features that pay big dividends there. And of course, we're doing performance and capacity analytics on cloud resources in the same way that we've always done it on physical resources. So see if any of these questions sound familiar to you. Our infrastructure customers, they want to know how they can improve resource utilization, simplify administration, and reduce costs. Now, there's a lot written in that statement, right? They certainly want to use servers more efficiently than they've been using them in standalone configuration. Analysts tell us that a typical standalone application server gets used maybe 10% of its capacity. They also want to simplify administration. If there's fewer servers to manage, then you need fewer administrators to manage all those servers, and they can focus on more upscale work. Reducing costs, of course, that's one of the leading goals of consolidation that customers are seeking when they move to the cloud. We've got hundreds and hundreds of standalone physical servers. Well, wouldn't it be great if we could have a smaller data center with lower electrical costs and lower cooling costs by consolidating that work onto a smaller number of host servers? And that's really something that's interesting to the operations team as well. They want to improve responsiveness and drive productivity, certainly, but they want to be more efficient, and they want to be more efficient, but not give up any of the service quality that they've always delivered in the past. And the line of business teams, well, they're thankful for that. They really want that notion that by giving up their individual servers and moving their workloads to the cloud, they're not having to give up any application performance as a result. So what really do we mean by cloud here? And this is a broad term that we don't need to get too hung up on and too worried about here, whether or not you're calling your virtual environment a cloud today or what private cloud really means. If you look at the gold box at the bottom here, traditional IT, well, that's where most of us started out, and that's certainly where our infrastructure management tools cut their teeth, managing data centers and servers and racks and so on. But as our customers have migrated those to a virtual environment, and maybe it started out as an experiment, maybe they had some test and dev workloads, well, virtually all of them now begun moving production workloads to the private cloud. The analyst data suggests that anywhere from 50 to 60% of production workloads are now running on cloud infrastructures. It doesn't matter so much if the customer calls it a cloud or not. If it's a virtual environment, it's running production workloads, you've got some requirements placed on it for service quality, maybe you're exploring automation, it's a cloud for our purposes here today. But if you consider that half of the workloads may have been moved to this private cloud, that does mean that half of them are probably still running on traditional IT. And whether you're at 50-50 or 80-20, it's a sure bet that you've got traditional IT and you've got private cloud workloads to worry about at the same time. So you're really squarely in a hybrid IT position. That means that you've got both. You're probably even considering public cloud and how you can burst excess capacity to public clouds and so on. So we're all squarely going to be stuck in this notion of a hybrid IT picture. And it's easy to find standalone hypervisor monitoring tools or separate vendors that specialize in monitoring a certain kind of a resource. The trick comes when you have this hybrid posture and you've got to look at all this data in the context of other types of data. We don't want to have four different management tools for four types of environments. We want one management tool that can monitor across all of these landscapes. So what is Smart Cloud Monitoring? How do we position it? Well, it's an entry point for cloud. If you looked through the IBM website and the IBM catalog of services, you most assuredly find an IBM product that manages any piece of cloud technology that you could dream of. We have solutions that span the whole range of cloud disciplines and cloud maturity. The problem is, as a cloud gets really complex, the solutions to manage it can get really complex. And a lot of customers who are early in their virtualization journey, and they're just starting to talk about their virtualized environment as a private cloud, they want to start a little more simply. They want something that they can deploy quickly, that will help them manage it efficiently without having to have as big a staff as they had to manage their traditional data center, and they want to be able to get it up and running quickly. And that's where Smart Cloud Monitoring came from. It was born out of the need to have something that we could deploy quickly when we decide it's time to rein in this virtual environment we have, and it's time to add a little bit of order to it because it's going to grow and we want to make sure that it grows properly. And so we want to track the performance, and we really want to keep track of utilization, ensure the reliability, and most importantly, because we know it's going to grow, we want to know that it's extensible and scalable. So what are the new features that we've added to our IBM infrastructure monitoring portfolio to make this product a cloud management product? Well, for starters, and the most visible thing would be the health dashboards we've added. These provide a consolidated glimpse into cloud health. If you imagine for a moment the number of CPUs and the number of network cards and switches and disk arrays and so on that make up a typical cloud, if we tried to look at those resources kind of on an individual basis, the way that our system administrators might have looked at those standalone application servers, well, it would be impossible for them to visualize all of the CPUs in a typical private cloud. The hypervisor vendor has taken all of those resources and they've pulled them into these notions of storage pools and pools of CPU. And so essentially they've abstracted the complexity of all those individual computing resources and placed it into the consumable, easy to understand bundles or pools of capacity. And so we've done the same thing with the tools that we're monitoring them with. Rather than try to look at individual resources, we've built these new dashboards that take a much higher level view. That allows a cloud administrator to very quickly assess the health of his cloud without focusing directly on each individual resource. Now, we've still got monitors doing very granular analysis of those resources, and we're recording performance metrics and availability metrics. And when some of those metrics are bad and we determine that there are problems in the cloud, we're going to report that, but we're not going to report it as an individual CPU that's down or struggling. We're going to report that this pool of CPU resources has a problem. And we can drill into the detail view if we need to, but we're going to offer the cloud administrator a much broader view so that he can make very quick health assessments without having to go into too much detail when he first sits down. Topology views are very important. If you see the view in the lower left quadrant of these dashboards, that shows the storage arrays, the NICs, the virtual machines, and the other components of a particular cluster. In this case, it's a VMware cluster. We've also created new Cognos-based reports. Our old reports tended to focus on individual resources or small groups of a particular type of resource. In order to capture the complexity of the cloud and cut through that sort of really abstract concept of these resources, we needed to produce a lot of new reports that captured the detail, but rendered it in a way that we could look at things more holistically. We also have introduced what-if capacity planning scenarios. As we know, almost any cloud that's running now is going to be the same size it is tomorrow perhaps, but it's going to have more work running on it. We've all got physical to virtual migration schedules that we have to answer to, and that means that we've got Department A is scheduled to move to the cloud by the end of this quarter, and Department B has to move to the cloud by the end of next quarter, and so on. In order for us to feel safe and secure about being ready to move those additional workloads to the cloud, we want to be able to model it. And we don't want to be able to model it in just a theoretical way. We don't want to look at the hypervisor and say, well, it says we have X amount of capacity left, and I guess there's room for Department A to move over here. No, we want to look at the actual performance of not only the virtual machines that are running on the cloud, but also those cloud resources, and take workloads that are similar to what we're going to move when we move Department A over, and we're going to model it, and we're going to say, yeah, there really is room in the cloud, or no, there's not, but we've got time to adjust things and expand our cloud capacity if necessary. An important part of that capacity analysis is policy-based optimization. And what that means is that we're not simply going to move workloads around in response to kind of a load balancing approach where we say, well, there's this cluster is kind of busy on CPU, but this other one isn't, so we'll just move a third of the workloads over there. Now, we may have perfectly valid reasons for wanting to run one of our clusters hotter than another. Maybe it's a test and dev environment that we don't want to allow a lot of extra buffer. But on the other hand, maybe we've got a really sensitive production environment that has seasonal bursts or other things that we want to take into account, and we don't want to fill up our buffer space that we've carefully allotted on that cluster with a bunch of test and dev workloads. The policies allow us to specify what gets moved where, what sort of buffers we allow for certain workloads, what kind of workloads do we want to have running on the same server, or perhaps more importantly, what kind of workloads do we not want to have running on the same server. It's a layer of intelligence and customization which we provide out of the box, along with a fairly convenient interface for creating your own policies and your own customization. Performance analytics for right sizing of virtual machines simply means that we're going to look at the performance of all the VMs running in the cloud. We're going to compare that performance, the resources they have actually used, with the resources that they have reserved or that have been allocated to them. In other words, we might have a bunch of workloads that we originally provisioned and assigned 2 CPUs to them, but they might be using typically a quarter of a CPU, which means that if we reduce the size of those VMs, we would be able to fit more virtual machines into the environment. So in essence, we have uncovered hidden capacity simply by looking not only at the performance of the virtual resources, but looking at the performance of the virtual machines as well. And of course, because this is built on the same IBM Tivoli monitoring infrastructure that our enterprise products are based on, we can integrate, remember that picture of the hybrid cloud, we can integrate with the tools that are monitoring our traditional IT environment, and we can bubble up into the higher level IT service management products. So I mentioned that we've created new visualizations, and this is primarily around the cloud administrator. The cloud tenants, they do need to see reports. They want to see assurances that their workloads are performing as they were performing on their physical environment before they moved them to the cloud. But they also want to assess how their applications are running so that when they need to add new workloads, they have a better picture of how to size those. But really, the bulk of the new visualization is around the cloud administrator. He's got this new role that is really focused around protecting the capacity of his cloud. Because it's so easy to provision new workloads into the cloud, it's very easy to burden it with more work than it can handle without really understanding not only the availability of the resources that are running, but also the performance of the virtual machines themselves. And that's why we created both of those disciplines in Smart Cloud Monitoring: virtual infrastructure monitoring and OS monitoring of the virtual machines. Because we believe that you can't look at either one of those things in isolation to really understand cloud performance. Let's take a look at the Smart Cloud Monitoring health dashboards that we've developed. These dashboards provide a holistic view of the health of the whole environment. As I mentioned earlier, the hypervisor has taken dozens or hundreds or thousands of computing resources and created pools of capacity for us to use in defining our servers and our clusters and so on. So when we want to look at the health of the cloud, we need to look at it from that perspective. Of course, we also need to be able to drill down into individual components when a problem is discovered. And that's why we've built this offering on top of the existing resource modeling and resource management tools in the IBM infrastructure management portfolio. We need the detail. We absolutely have to have the detail, but the cloud administrator doesn't need to see the detail to be able to assess the health. He needs this holistic view, and if he does spot a problem, of course he needs the ability to drill down. Here's a closer look at the dashboard. If you'll notice this scorecard widget, we've got a bunch of clusters listed here in our test environment, and you see some red X's under server and storage. In this case, we're ranking the clusters that have the greatest number of reported problems at the top, so that we see our problem children right away, and we can click on those. These views are all context sensitive. When we click on one of these clusters, the views on the right, that in this case cluster servers and CPU and memory and so on, are repopulated with data. We can change these views around. We can right click on any of these elements and view the new reports that we mentioned that are cloud focused. Of course, the cluster architecture view here gives us a neat way to understand the topology of each of these clusters, so that if we are experiencing a problem, we can quickly see which virtual machines are affected, which of our host servers might be at fault, or which network or storage resources could be contributing to the problem. And in all of these cases, we can drill down and begin to do some root cause analysis and diagnostics. In this case, we're looking at a VMware storage sample. Once we have drilled down to the point where we identify a specific resource that's a problem, the cloud administrator can open a very targeted, very detailed help desk ticket to get for perhaps a storage administrator or a network administrator to address the very specific problem that we have drilled into. So I mentioned at the beginning when talking about the new features that capacity planning was particularly important in this arena. Capacity planning helps us consolidate and reduce costs, and when we go back and look at why we started virtualizing in the first place, or ask our bosses, what's the reason, what's the big driver behind virtualization? Almost invariably, reducing costs and consolidating is number one. Electricity costs have gotten so high, hardware and labor costs have gotten high, even floor space in the data center has gotten very expensive. So consolidation is really one of the keys. And in order to consolidate, we've got to understand how hot we can run. How densely can we pack workloads onto this environment and still have it run safely? Capacity planning also helps ensure application availability. Are any of our resources overloaded? When will our physical resources reach their limits? Can our supply meet our demand, and are we meeting our business objectives? And as I mentioned, capacity planning also helps us optimize resource utilization. And it does this from both ends. Not only can we optimize the placement of our virtual machines to make best use of the pooled resources, but we can right size those virtual machines themselves to make sure that they're not consuming or reserving any more resource that they need. And here's a look at how the capacity planning and analytics solution works. It looks like kind of a complicated chart, but really it's a pretty simple concept. In the gray cloud at the bottom, we see all of the network, server, and storage resource monitors that we have. This is the monitoring component of Smart Cloud Monitoring. We take that data, which is stored in the Tivoli data warehouse, and we federate it into the capacity planning database. By creating a new database just for the capacity planning tools, we're able to customize it. We can import tags into that database through a simple spreadsheet, And we can tag particular types of workloads or host servers with anything from a department identifier to a customer name. And that allows us to do very sophisticated plans and optimizations that are highly customized. I mentioned those policies you see in the upper left here, the business and technical policies that are going to govern what the recommendation looks like. We also apply benchmarking data, which is really important because to a hypervisor, a CPU is a CPU. But to a system administrator who's looking at CPU power and capacity, he knows that some of the CPUs in that cloud are much faster than some of the others. Same goes for storage. Different types of storage can have much faster I/O throughput capabilities. By applying benchmarking data to the inventory of resources, we now have the ability to do things like run our highest importance, most critical workloads on our fastest CPUs, or by contrast, maybe we take our test and dev resources, workloads, and we run them on our slowest CPUs. It's just a level of customization that isn't possible if we're only going to use the hypervisor vendor tools to allocate workloads. And the result of all of this chewing and processing by the analytics engine is a plan recommendation. Now, just to sort of review what the solution looks like, it's the entire cloud ecosystem, really. What you see in the purple boxes are different storage arrays, Hitachi, EMC, NetApp. What you see in the green in this example, these are our host servers. In this case, we've listed ESXi servers. Of course, we've also got our network switches as well. All of that data is fed into the virtual infrastructure agents, the monitoring agents, that feed here into the Tivoli monitoring infrastructure. We've combined that data with Tivoli application discovery and dependency mapping, which is optional, and we combine it into the health dashboard views that we saw earlier. Essentially, we have a monitor in IBM for just about any resource that you would find in your data center. And because we didn't build a new infrastructure, because we didn't reinvent the wheel, if you will, you're able to plug any and all of those agents, whether they're included in this Smart Cloud bundle or not, you're able to plug them into this environment and share the data so that you have full spectrum analysis of the entire cloud ecosystem. I mentioned earlier that we've created a lot of new reports around virtualization management and cloud management because it requires a more holistic way of looking at resources. Take a look here at the CPU utilization chart with the purple bars. The blue bar shows what the mean CPU utilization is across these clusters. And you can see very quickly that things appear to be very imbalanced. Ordinarily, if we were just looking at CPU utilization, we would be tempted to address this. We don't have anything that's really causing a big problem yet, but just having things out of balance isn't an efficient way to run our cloud. So we might ask one of the hypervisor's automated tools to spread some workloads around for us, and let's try to balance out this CPU utilization. However, with this new report that shows data store space, CPU utilization, and memory utilization all in one view, we would very quickly see that this cluster, test cluster, is almost completely maxed out on its data store utilization. When we look above at test cluster in the CPU chart, it's very low. So that might have been a really tempting place for us to move a bunch of workloads to. However, imagine what would have happened if we had added a bunch of new workloads to test cluster. It would have run out of available space, applications wouldn't be able to write their log files, and work would stop. Heterogeneous management has long been Tivoli and IBM's infrastructure management hallmark. We used to have t-shirts and mugs that said manage anything anywhere. And that continues with Smart Cloud Monitoring. Rather than focus on a single hypervisor platform, we've developed monitors for a number of different hypervisors. VMware, KVM, Citrix, Hyper-V, as well as Power and ZVM. That gives our customers the flexibility to choose whichever hypervisor is best suited to their workloads, or even comparison shop between them, or, as has become really common, to run 2 or 3 different hypervisors in their data center, but not have to have separate tools to manage each one. And of course, as I mentioned, we've got a monitor for everything. different operating system, applications, middleware, databases, and so on, all of which, while not part of the Smart Cloud Monitoring bundle today, can be plugged into it. So to summarize, what does Smart Cloud Monitoring provide? Well, it's optimized cloud performance, and it gives you the data that you need and the tools and the analytics to maximize the ROI. And we do that by providing greater visibility into cloud health. It's no longer this sort of amorphous thing that's running where we're totally dependent on hypervisor charts to tell us if things are healthy. Now we're looking at those hypervisor metrics, but we're also looking at the workloads themselves and viewing those two things in context with one another. Smart Cloud Monitoring helps us lower our total cost of operations. By optimizing our workload placement, we can wring maximum capacity and performance out of our cloud investment. As I said earlier, we almost always find that we have more capacity than we realized once we start doing some analytics on the workloads. And of course, we're going to optimize cloud performance because we're still going to look at performance metrics for all of our applications and all of our resources. But now we're able to tune things a lot more flexibly, simply by putting, for example, WebSphere and DB2 virtual machines on different host servers. We can improve performance by spreading I/O throughput across. So with years of experience managing mission critical workloads in the world's largest enterprises, we understand performance, we understand best practices, we understand availability, and we understand the need to keep mission critical workloads running seamlessly, whether they're on a standalone server or whether we've moved them to our cloud.
I'm going to now show you a demo of the Smart Cloud Monitoring solution that Marvin just talked about. On the left-hand side, you can see all the major components of what makes up that Smart Cloud Monitoring solution. So you can see we've got monitoring agents for Cisco ECS, Citrix, networking, storage. We've got our predictive analytics through Performance Analyzer, as well as VMware monitoring. And I'm going to pick out a couple of these and take a look at them. Here you can see our VMware monitoring, where we're showing you at a very high level the clusters and the ability to drill down through these links to get to more levels of details. And if I expand this, you see we've got detailed metrics on each of the ESX servers and CPU metrics, memory metrics, etc. I'm not going to go into any level of detail here. Now, I do want to show you one more thing before we move on. I want to show you the Performance Analyzer because I think this is a really key part of your monitoring application. The idea here is to become very predictive and proactive about how you do your monitoring. We could do linear trending analysis on our metric data and determine whether or not we've got capacity left. And it looks like in the case of VMware, where things are looking pretty good from a CPU perspective, but we've got analytics here for memory, for disk, for many other metrics. We've got the ability to do both nonlinear and linear trending. If I look at, say, a nonlinear trend for the operating systems, you can see that as I look at this, it actually picks out the best statistical model for the actual data that I've got. So it's got 3 or 4 different models depending on which resource I'm looking at. Here's one that's got Holt, we've got Winters, we've got ARIMA, a number of different models. But most importantly, we identify how many days we have left until we're going to run out of capacity. So here, I've got 48 days till I hit my warning threshold and 68 days until I reach my critical threshold. And then here's one where I'm actually past my threshold already. So I've got to pay attention to those systems, and I can use some of the tools like our capacity planning tools and some of the other monitoring tools to see what's really going on that given system. Now let's take a look at our tip dashboard. What you're looking at is our health dashboard for VMware. And as you can see, I've got a very high-level summary of all of the clusters in my VMware environment across multiple data centers. And we give you a very high-level summary of what's healthy and what's unhealthy. So you can see I've got a number of server-related problems. If I fly over one of these, you see the situations that are triggering. On the right-hand side, you see a set of metrics. They can be either real-time or historical. It's all contextual. So if I select a different cluster, you're going to see the metrics on the right-hand side change to represent that cluster. I also have the ability to do a right-click, for example, and run a set of reports that are filtered down to the selected cluster. If I scroll down further, there's some additional metrics as well as sort of a physical topology of what makes up that cluster down in the lower left corner. And I can also do things like drill down into the resources. If I click on one of these clusters, I can drill down, for example, into the storage and look at some of the details of what's happening. As you can see, I've got one of my data stores selected, and in the middle of the screen you see the virtual machines in this cluster that are running on that particular data store. And then, of course, the graph on the right-hand side represents the individual server that's being monitored. These graphs are configurable, so I can select the metrics that I want to show. Some of them only have a couple metrics, some have more. But I can show whatever I want on these screens, and as I scroll down, there's some additional metrics as well. Now, in my environment, I've got this integrated with Tatum, and Tatum is doing change discovery. The resources that I selected, you don't see any changes that have occurred, but if there were changes that occurred on this particular data store, you would see, for example, that an additional virtual machine was added to this data store, or machines were deleted from the data store. In the case of looking at a server level detail, you might see changes in the resource allocations. For example, I increased the amount of memory on a virtual machine. All those kind of changes are captured and are represented in context with the data that you see on the screen. With that, let's take a look at some of our reporting. Here you see our Tivoli Common Reporting tool. I'm going to focus on the virtualization reporting, but know that there's a whole bunch of other different kinds of reports that you can install into this Tivoli Common Reporting tool. So you can see I've got installed here reports for power systems, for Citrix, for operating systems, for Hyper-V, Cisco UCS. But again, we'll focus on the VMware reports. And there's 3 different categories of reports along with some prereq checking. The first category involves doing performance trending and analysis. I'll just select this first report and give you a sample. And it's just giving you a high-level summary of key metrics like CPU, memory, etc. for each of the clusters. I like this report. It's a nice simple report showing a summary of all of the key metrics across all of my clusters. So at a glance I can look at all the key attributes. The yellow line represents the high water mark during this 7-day period, and then the other line represents the real-time data over that period of time. And you can see that I have a link here, and I can drill into any one of these clusters and get down to a more detailed level view, which would show me all the ESX servers, a very similar type graph for each of those, and then I can drill down further into an individual ESX server. Now let's take a look at the next category. I've got some what-if analysis that I can run. The idea behind these is to find out whether I've got capacity for additional workloads or to understand how much capacity is left. So when I run this report, you'll see that based on my current average utilization, I've got room for 19 virtual machines based on memory. Memory is my bottleneck right now. I've got plenty of capacity for data store space as well as CPUs. Now I don't have to use averages. I can use user-defined settings and, for example, specify that the virtual machines are going to use 2 gigahertz of CPU or 3 gig of RAM and let it go through and do the calculations again. And the last category of reports that I'll show you is what we call right sizing and balancing. I'm only going to show you one report here, but you notice that there are some top 10, bottom 10 reports. The one that I like the best is this load balancing report. And it very quickly shows that in my environment, I've got a serious imbalance between CPU and particularly data store space. You can see that this one is over 90% utilized, whereas I have others that are in 30, 20%. CPU is probably more of a concern for me, but I've got one cluster set up running at 57% utilization. Meanwhile, I've got another one running at 2%. I wouldn't want to do this in a production environment, right? I have these running this way intentionally so I can show some nice demos and show you what the tool can do. But ideally, you want these to be balanced across all these key metrics. The main idea is this report can identify a problem and an imbalance in the environment, and then we can use the capacity planning tools to help you solve this problem, right? Maybe get better optimization out of your hardware, and better utilization can save you money in terms of licensing costs. It can save you in terms of the number of servers you have to run. So we're going to go into the capacity planning tool now and see if we can solve this problem. The idea with the capacity planning tool was to make it very, very simple. 5-step process. You can literally go through and click the 5 buttons and go through the entire process. The first button I'm going to skip. All it's really doing is loading configuration data from Tivoli Monitoring into this tool, and I'll show you that configuration data when we get to the third step. The second step is to set the time interval. I'm going to evaluate data from January 1st through the end of the year. The third step is to define the scope, and this is where things get interesting. You can see that it's loaded in all of the information about my data centers, clusters, and ESX servers. There's a couple things that I want to point out on the screen. The first is that we have this architecture field, and we have all of the CPU types identified. Now, We do have spec-int benchmarks built into this tool, so as we do our capacity planning, we're tying our optimization to the actual performance of each server. If anybody tells you that they're accurately doing any kind of predictive analytics or capacity planning without the benchmark data, they're fooling themselves. Just a general CPU utilization number is useful data, but relative to benchmark data where I really understand the capacity of a server based on the number of cores, the amount of memory, and even to some extent the hypervisor version, I'm really being extremely accurate about how I do my workload placement. Maybe I want to run my mission critical applications on my fastest machines, and I can do that by knowing what the architecture is. As I scroll over to the right hand side, you see that I've got a field called server age, and that's a field that I added in. I'm able to import data in from a CSV file and populate fields like this and then use that as part of my capacity planning. The thing that we like to say when we talk about our capacity planning tool is we like to talk about policy-based optimization and having those policies tied to your business objectives. A simple objective here might be, I want to run my mission critical applications on my newest and fastest hardware. I want to run my dev and test machines on my slowest hardware. So I can base that on the server age or a number of other factors. I can view the virtual machine inventory. In this virtual machine inventory page, you're going to see that I've got a number of different things about the virtual machines, how much CPU, memory, etc. But what I really want to point out on the screen are the last three columns. I've got the middleware name, mission criticality, and what the primary business application is. And this is where we really try to tie this into your business objectives. If I can identify through, say, a CMDB, the line of business that this particular VM supports, then I can build rules for my capacity planning and optimization to take that into account. And I can, for example, say that my mission critical business applications are going to get extra capacity, or my infrastructure or dev test machines are going to get less capacity based on the needs of the business. The next step is to go in and look at the virtual machine utilization. I'm going to select all of the resources and I'm going to come into this actions tab and I'm going to compute the usage. I can do that in a number of different ways. I'm going to select initially hourly data, and you'll see that I have the ability to select a certain subset of hours. Maybe I want to look at the peak shift data only. If I select daily data, I might want to select weekdays only and not do weekends because my workloads are different during the week than they are on the weekends. For simplicity, I'm just going to go ahead and select daily data and do all hours of the day and all days of the week. I can also do this based on average, minimum, maximum, or 90th percentile for the data over that time period. It's going off and it's calculating the current CPU utilization over the period of time starting January 1st, and it's come back with these utilization numbers. I can also come in and compute the workload stability type. Again, I can do this based on things like min, max, or average, and it's finished running and come back with a stability type. The idea with the stability is to understand whether the workloads are very stable or unstable, and from an optimization standpoint, ideally I don't want to put a whole bunch of unstable workloads on the same physical server because there's a chance that as those workloads spike, they may all spike at the same time and I may run out of capacity. If I can mix a set of stable workloads with one or two unstable systems, then I can get lower risk in my environment because I know that I'm not going to have 10 or 12 virtual machines spiking simultaneously. The next step is to come into this Actions tab and edit the utilization. You don't have to do this, but it's an optional thing that I can do. For example, I can plan for some growth. Maybe that growth is due to a new business application coming online. Maybe it's due to an acquisition, or maybe it's just growth because I know over the past 3 years I've grown at a rate of 50% in my VMware cloud environment. So I can plan for, say, 20% CPU growth, 10% memory growth, 40% data store space growth, 20% network growth. And now when I save these changes, you're going to see the numbers on the screen get updated to reflect those increases. So from this point forward, all of my calculations, all my capacity planning is going to take that growth into account. I'm done with that screen and I'm going to go back to the planning center. And I could click on this size VM, but essentially all it's doing is doing the exact steps that I just went through on the previous screen, but it's really more for a novice user. So I'm going to skip to the next step. I can run a current environment report. I'm going to click on this and I'm going to let that run. It takes a few minutes to run, and while that's running, we're going to go back and click on the next step in the tool. So the next step is to generate the capacity plan. Now, before I do that, I'm going to come in and edit the recommended environment settings and get into a little more granularity. Here you see a mixture of some out-of-the-box rules and some rules that I wrote. The idea is we categorize these rules into things like co-location, anti-location rules, where I might say, for example, I don't want to put DB2 and Webster on the same ESX server because I know that those workloads are both very high I/O rates, very high memory utilization, and to some extent CPU utilization. It's better if I can put those into separate environments. environments. I was talking to a customer the other day where they indicated that the way they get charged for their Oracle environment is they pay per cluster for their Oracle licensing. So they wanted to intentionally put all of their Oracle servers in the same cluster, right? So you might write a rule to ensure that that occurs. We have boundary conditions. So for example, we may want to place as many Windows 2003 32-bit systems on the same ESX servers as possible. And the reason we do that is because if I run the same OS type on the same physical server, VMware can do more memory sharing because it can load the DLL once and it can share that across multiple images. And since your licensing fees based on the amount of memory used, you can lower your licensing costs by lowering the amount of memory. And you can see that I've got similar rules for Windows 2003 64-bit, Windows 2008, so a couple of Linux flavors that I run in my environment. And by doing this, I can get better utilization out of my system, specifically in terms of memory. I've got rules like provide more capacity for my mission critical VMs, or here's a business application where I want to provide more growth for a particular app called Online Quotes. Again, you can do this for any application that you want. You can write these rules very easily. They're XML based. You can take these and use them as templates, modify them. Very, very easy to create your own rules to meet your business objectives, right? And that's the key here as we do this capacity planning, is to tie it to your objectives, not generically do optimization. So once I'm done, I select as many rules as I want, and I've got several selected here, and I go back to the Planning Center and generate the capacity plan. As you can see, the report has finished, and there's a couple things I want to point out. One is, at the top of the screen, you see that I started with 9 ESX servers that I evaluated. Now, I only evaluated the clusters that were in my Austin data center. I've got 2 data centers, one in Research Triangle Park and one in Austin, Texas. I started with 9, and what it's telling me is I could actually run the same workload on 4 physical servers, so I could eliminate those servers, save on power, cooling, the management costs to maintain those servers. And you can also see that the memory has decreased as well, so I can actually eliminate some memory, eliminate my VMware licensing costs. So I can get some considerable savings here by running this tool and using the optimization that we're recommending here. Now, as I scroll down here, you'll see a couple different things. We give you something called a capacity efficiency index, which is an indicator of how efficiently am I using that hardware. And we start from the top down and work our way down from the data center down to the clusters, down into the ESX servers. And we give you a report on the expected utilization before and after optimization. We give a little headroom to make sure you never run out of capacity, and we show you the unused capacity. And as I scroll down, you're going to see for each of these major components down to the individual ESX servers, these are the systems, and these are the virtual machines we recommend you run on this particular system. The other thing that I think is really important is that we also try to help you do what's called right sizing of the virtual machines. You can see here I've got a CPU reservation for each of my virtual machines. What we're telling you is for all of these virtual machines, we recommend that you decrease the CPU allocation because we're not using anywhere near the reservation. And so essentially I've over allocated every single one of these virtual machines, and all of that capacity is going to waste. We do the same thing with memory. We've got a current reservation as well as a recommended reservation. In some cases we're actually going to tell you to increase the reservation. Right, here's one where we're increasing it slightly. This one doesn't have any current reservation, but in many cases we're actually telling you to reduce the memory reservation because you've never come anywhere near the actual utilization on that server. So by doing this, I can actually reduce my consumption by ensuring that I don't over allocate my resources, but under allocating is just as bad. If I under allocate my mission critical applications, I run the risk that they're going to run out of capacity when other virtual machines spike, and I don't want that to happen. Now, for a dev or a test machine, that's probably not a bad thing to under allocate them. Those are applications that if they run slowly, it's okay. You don't want to necessarily eat up system resources on your virtual environment. And as I scroll down, you're just going to see the rest of the environment, right? All the clusters, all the data centers, and all the virtual machines and where we recommend you place them. Now keep in mind, right, we understand that you have DRS and vMotion enabled, and VMs within a cluster are going to move around. The idea behind this report is we're giving you a recommendation on moving virtual machines between clusters so that you can get the best optimization. Now think of an environment where I have one cluster that's running very high CPU, another cluster is running very high memory utilization, another one is running very disk I/O intensive workload. If I can balance those resources, I can get better optimization and better usage out of all my hardware. Now let's take a look at the last report. We've got this current environment report, and the idea here is similar in nature. We give you some usage information about the environment. I'm scrolling down to the bottom, and you can see as I scroll down we've got the CPU utilization details, the recommended usage, as well as the current reservation for memory and for CPU. And then we've got this thing called the performance risk index. And the idea with this is if I've either under or over allocated a set of resources, or maybe I've got a whole bunch of virtual machines that are running an unstable workload and they're running on the same ESX server, or my resource pool is overutilized, my cluster is overutilized, I'm putting those virtual machines at risk. So what I want to do ideally is minimize the risk across my entire environment, right, so that I don't have a lot of risk. I don't run the risk that I'm going to run out of memory or CPU capacity for any of my virtual machines. By identifying which ones are at risk, we can help you minimize the risk in the environment and keep your availability high. At the same time, we're also optimizing this environment to get the best utilization out of the environment that we can.